Okay, you guys, let's go over this one. Statics practice number 3. We got a couple of different tricky problems in here. This one right here is a little bit tricky because our tensions, our angles are not the same. So this is going to be a little bit of a challenge. The other two, not so much. So let's talk this one first. All right, so your free body diagram. You should have gravity going straight down, right? And then you've got two different tensions, one up here, one over here, and I know that's not to scale based on what's going on. All right, so here's your ceiling, right? Your angle here, your 23.8. Remember, you've got alternate interior angles here, so it's going to be the same right over here. All right, so that's going to be my 23.8. My angle here, my 81.8 is going to be the same right there. Okay, so based on what I know, what I'm going to try to do is to have up equals down, left equals right. And as you can see, I don't have, my two tensions are pointing in different directions. So I'm going to need to do T1x, T1y, and I'm going to just call this one T2x, T2y. Now just a word about vectors here. Okay, when we do these vectors, your hypotenuse is obviously the tension itself, right? But remember, your legs have to go head to tail. All right, sometimes I get crazy people trying to tell me that this T2y is trying to point down, and I'm thinking, really? Then why isn't it falling on your head? All right, so be smart about this. This is going up and to the left, so therefore you have to go to the left and then up with your other vector. And this one is going up and to the right, so you want to go to the right and then up with your other vector. All right, that's kind of key and critical. So let's continue. What can we figure out? We know the mass. We know the mass here, and we know that m little g is going to be Fg. So let's start with what we can figure out right away. So 12,250 kilograms times 9.81 meters per second squared. All right, when I do that, I get an Fg of 120,173 newtons. Okay, the good news is that I know that T2y plus T2x, oh, sorry, not T2x, my bad. Let's try that again. T1y has to equal Fg, because up equals down. Left also has to equal right, because this is an equilibrium, right? We have constant velocity of 0. So what I'm going to do here is I'm going to take I'm going to get to a point where I'm kind of stuck, and then I'm going to use my second equation over here to help me out. So if I consider, let's start over here actually with our simpler one. All right, T2x equals T1x. What I'm going to do is I'm going to take T2x and I'm going to put it in terms of just T2, right? So what I know is that T2, what's my angle there? 23.8. Okay, times the cosine of 23.8, right? That's another fancy way of saying T2x. That is going to be equal to T1 times the cosine of 81.8. Okay, now if I rearrange this to get T1 by itself, T2 cosine of 23.8 divided by the cosine of 81.8. Well, the nice thing is the cosines are numbers, so what I'm going to get is that, I don't want to hit the record button by mistake here. T1 is going to be equal to, I'm just going to go down there a little bit, all right, 6.41 T2. All right, double check my math there, but I'm pretty sure that's correct. So how this is going to help me is when I set up this next part over here. All right, now I know that this is 120,173 newtons over here. T1y, that's going to be a sine function. So this is going to be T1 sine of 81.8 plus, oh, I'm sorry, that's a 2. That's T2. and then this one is going to be T1 sine of 23.8. Okay. You can see I've got two missing variables, and this is an issue. So I'm going to substitute this right there. And then it's going to go down to one variable, and I'm going to be able to solve it with no trouble. Plus, let's put it in. I'll just put it in parentheses to try to make it neater. Good luck. We all know how good my handwriting is, right? Okay, so there we go. The nice thing is I'm going to be down to T2 equals before you know it. All right, so when I do a little bit of math here, you know what? I called these different letters before. Give me 1 second. Okay, in classic Grady style, I have made a math error. So let's erase. All right, that part is correct. This part, we're going to get rid of this down here, and we'll get it going on again. There we go. All right, so I redid the math here. This is actually 0.237 T2 equals T1. All right, let's try this again. So I am going to plug in the same spot, but I'm going to plug in obviously a different value so that it makes some sense. All right, T2 sine 81.8 plus 0.237 T2 sine of 23.8 equals 120173. Okay, now let's multiply that times the sine of 23.8. Wait a minute, are we in radians? Oh no, I'm in radians! Darn it! Oh my gosh, okay. I got caught with the radians again, you guys. I don't believe it. I can't believe it. It got me. All right, let's get rid of this again. Third time's a charm, right? Even for me. All right, we're gonna clean it all up. We're gonna clean it all up because I keep losing all my numbers here. Let's try this one more time. Oh, lo and behold, I was right the first time. All right, T2 equals T1. The heck with you, radians. All right, let's try this again. T2y plus T1y equals FG. Okay, so T2y is going to be T2 sine of 23.8 plus T1 sine of 81.8 equals 120173. Okie doke. Now, let's just do this a little bit differently. 0.403 T2. I will be happier when I am in decimal land. That is where physics people like to live. Plus 990 T1 120173. All right, now I'm going to take this and put it there. One 20173. All right, we got this. 6.34 T2 plus 0.403 T2. I'm just going to do the algebra here, and then I will get to it. All right, and we're going to add on our 0.403, 6.75 T2 equals 120173, and do some division. Oy, oy, oy. Eventually we'll get to an answer. Okay, so I get T2, gosh, I'm almost out of room here. I'm going to squeeze it over here. T2 equals 17807 newtons. All right, so there's T2, and you can imagine the rest. I'm going to take that value and I'm going to put it right there, and I'm going to solve for T1, and I'm going to get for T1 114 newtons, and there's that answer for that one. Oy vey, I hope it didn't take you as long as it took me. All right, next question. Luckily, that was the tough one. Let's do the easy ones. Looking forward to the easy one next. That'll be good. All right, so this one's pretty straightforward because you've got something flat and you've got the coefficient of friction. It's a really easy free body diagram. So there's your birdseed. Here's mg, normal force. You're pulling it, that's most likely a tension. And then you've got friction. All right, since you are moving with constant speed, which is told right there, you've got to have balanced forces. This tells me that tension will equal the force of friction. Normal force will equal the force of gravity. Okay, and you're given the coefficient of friction. So if you're given mu, the nice thing about that is we know that that's the force of friction over normal. Or a lot of folks like to write it this way, just because it's easier for them to work with that. Okay, so let's start with what we can figure out. All right, we've got 98 kilograms for a mass. Let's multiply that by 9.81 meters per second squared. And in terms of gravity, we're going to get 961 newtons. That's going to be the value for FF and FN. Or, I'm sorry, FG and FN. Okay, so now that I've got that, and I want to talk about, I can work with the mu value that they give us in the question. So 0.445 is my coefficient of friction. I'm going to multiply that by 961 newtons and get friction force of 428 newtons. All right, so that's my friction force. Now, considering that I know that these have to be balanced, that tells me the force that you're going to apply is exactly the same thing. Ooh, that one didn't take us long at all. Hooray. All right, let's move on to the next. Two-body system. We want to keep the blocks at rest, so we're looking for balanced forces. All right, draw two free body diagrams. Here's the hanging mass. All right, I'm going to call this one M1. Let's call this one M2. That'll make it easier. All right, so M1G is going down, tension is going up. When you're dealing with M2, all right, we've got going straight down, you've got M2G, right? And we've got normal, and we're looking for the coefficient of friction to keep the blocks at rest. Since they tell us, look how much smaller that one is to this, you know it wants to go that way. Like if you didn't have any friction, you would be going this way. So that means that your friction's got to be going this way in order to help prevent the motion, right? So let's put in friction going that way, the same tension going this way, and we're going to break this one up into M2G sine of theta, and this one is M2G cosine of theta, and there's theta, which is 43 degrees. We already know that. Okay, so now what I'm going to do is I'm going to, well, you know what, we'll do some figuring in a minute. Find the coefficient of friction. All right, so if I want the coefficient of friction, that's going to be the friction force on the normal force, right? And so I got to figure out my friction force, but my normal force is pretty easy to figure out because it's got to be equal to that. Those two must be equal, right? Otherwise, that wouldn't work out so well. Right, we got to have those two. They're equal and opposite. This block is not lifting off the surface. It's also not sinking through the ramp itself. So let's find Fn. Fn equals mg cosine of theta. What's our m? 8.6. 9.81 cosine of 43. And hopefully I did the math here. I did. I got, nope, sorry. That was for a different part of my question. Oops. All right, that is a pain. How am I supposed to, 8.6, 9.81. 57.81. Let's try that one more time. Okay, I think I got 57.5. Let me look on the right part of my answer right there. So 57.5 is the normal force. So that gives me the bottom. Now I just got to find my friction force. So my friction force, that's not going to be so hard. But I am going to have to work with the whole up and down the plane thing, like the up and down the hill thing going on here. So let's start with this one right there. All right, so if we are keeping the blocks at rest, that tells me that tension must be equal to M1G. Okay, so that's for that one. Excuse me. For my next body, let's think. What's trying to, you know, the tension's trying to pull up. So let's see, my tension trying to go up the hill. Right? Actually, you know what? I'm going to flip these around just to make it easier for us to see. Just give us a little more room to work. All right, so this is going to go up the hill. Right? Tension's trying to go up the hill. What's trying to go down the hill? Friction and mg2 or m2g sine of theta. That's trying to go down the hill. I'm going to add those together. You can see the tensions cancel out. Like that. And so my friction, when I rearrange this, is going to be equal to m1g minus m2g sine theta, which looks ugly, except I have all those numbers, right? It's not that big of a deal. And in fact, if you want to get crazy, you can pull out the g, but you're just delaying the inevitable plug and chug. All right, so 9.81 m1 8.6 minus 11. Oh no, I did them backwards. Darn it. And I managed to knock off half of my stuff here. Son of a gun. M2G. I'm sure you get better at this as you go. I am not an expert in erasing. Okay. Let's try this again, shall we? All right, I'm not even gonna rearrange it. I'm just gonna skip that step. All right, M2 is 8.6 times 9.81 times the sine of 43 degrees. And I am gonna go and grab my calculator. Thought I had it. But I don't think I do. All right, so 11 times 9.81 minus 8.6 is 9.81 times sine of 43. Okay, and I'm getting friction of 50.4 newtons. I do not believe this is what I got before. So I'm kind of wondering about that one. Like, what did I do differently this time? Not sure. Well, I'm sure some of you guys can take a look and find it a little bit later. See if I've made a math error someplace. All right, so when I go over this one, 57.5. Oh, actually, that's pretty much the answer I had before. It's a little bit higher, but perhaps I just rounded somewhere and I wasn't thinking. All right, so 0.88 from you. All right, there we go.